In this lesson, we are working on the relationship between different means of two non-negative real numbers. By definition, if A and B are two positive real numbers, harmonic mean of A and B is 2 over 1 over A plus 1 over B, which can be simplified as 2AB over A plus B. Geometric mean of A and B is square root of AB. Arithmetic mean of AB is A plus B divided by 2, and quadratic mean of AB is square root of A2 plus B2 divided by 2 when A and B are non-negative numbers. The relationship between different means is harmonic mean is smaller or equal than geometric mean, it is smaller or equal than the arithmetic mean, it is smaller or equal than the quadratic mean, and quadratic mean is smaller or equal than the maximum of two numbers, and harmonic mean is greater or equal than the minimum of two numbers. We already proved and used geometric mean of A and B is greater or equal than the arithmetic mean of A and B. Let's prove geometric mean of A and B is greater or equal than the harmonic mean of A and B when A and B are two positive real numbers. We know square root of A minus B to the power of 2 is always greater or equal than 0. Therefore, A plus B is greater or equal than 2 square root of AB. Just expand this inequality and bring 2 square root of AB to the other side. We could use this directly by using arithmetic mean, geometric mean inequality. From this inequality, we have 2 square root of AB divided by A plus B is smaller or equal than 1. If we multiply both sides of this by square root of AB, we have 2AB over A plus B is smaller or equal than square root of AB. This means harmonic mean of AB is smaller or equal than geometric mean of AB. Equality holds when A and B are the same. Let's assume A is the minimum of A and B. If A is the minimum of A and B, then 2AB over A plus B is greater or equal than 2AB over two A. Which is B. We know when we increase the denominator of a fraction, the fraction is getting smaller. A is bigger than B. If we replace B with A, the fraction becomes 2AB over 2A, which is B, and it's smaller than the harmonic mean. This means minimum of A and B is smaller or equal than the harmonic mean of A and B. Let's prove the arithmetic mean of A and B is smaller or equal than the quadratic mean of them. A minus B to the power of 2 is greater or equal than 0. A2 plus B2 is greater or equal than 2AB. It's also the arithmetic geometric mean of A2 and B2. We add A2 plus B2 to both sides of this inequality, and the rest of the proof is very straightforward. The other side is A plus B to the power of 2. We divide both sides by 4, and we take the square root from this inequality. This proves arithmetic mean of A and B is smaller or equal than their quadratic mean. We assumed B is the minimum of A and B. Therefore, A2 plus B2 divided by 2 is smaller or equal than A2 plus A2 divided by 2, which is A. This means the quadratic mean of A and B is smaller than the maximum of A and B. Notice that A is the maximum and B is the minimum with our assumption. Thanks for watching.